Oh. All right. Hi, everyone. I'm Lindsay.
I'm Noah.
I'm Ember.
I'm Zoe.
I'm Kaden.
And today we're presenting on microbes and their impact on human health. So, what is a microbe? So, the term microbe is a general term that refers to a microscopic organisms that cannot be seen with the naked eye normally. These microbes can be found in nearly every type of environment, and the ones that are found in the harshest environments are called extremophiles. Many microbes impact human health. The first is bacteria, which are single-celled prokaryotic organisms. These have peptidoglycan in their cell walls, which is important because it's a common target for antimicrobials and like medications. And then we have viruses, which are pathogenic microbes that consist of only genetic code in a protein case. They don't have their own organ systems. They have to rely on a host. And then we have fungi, which are a large range of heterotrophic organisms, think molds, mushrooms. And then protists, which are a diverse group of eukaryotic organisms. Different microbes can be both beneficial and harmful to human health. So while we do think of bacteria as typically being bad, or well, all viruses are bad, but microbes as being bad, they're actually a lot more helpful strains than there are harmful. So now we will go into beneficial microbes. So most microbes are actually beneficial. One crucial way that microbes help is in digestive processes. So the human digestive system can't break down or produce vitamins like vitamin K and folic acid. So we rely on microbes in our gut to either break those things down or produce them for us. Beneficial microbes also send signals for our bodies to make vasculature to and from the GI system, which helps obviously absorb the nutrients that we get into our bloodstream. And they send signals for our bodies to produce antimicrobials that target pathogenic or bad microbes. They also produce antimicrobials themselves. So they're also very important for skin health. And actually, at any given moment, you have more microbes in and on your body than you have cells in your body. Microbes are also really important in antibiotic and insulin production, as well as commercial vitamin production. So they do play a big role in a lot of medically related processes.
And then on the flip side from beneficial, some pathogenic bacteria. So pathogenic bacteria to cling to host cells, avoid detection of the immune system, and cause infections in the host. Some examples are like E. coli, tuberculosis, and some calmer strains like strep throat. A wide variety of infections can cause from minor skin conditions to serious systematic diseases. This is facilitated by their capacity to form biofilms, withstand antibiotics, and take advantage of host environments. Gaining an understanding of these fundamentals is essential to creating strategies that will effectively prevent and treat bacterial infections, thereby tackling persistent issues in public health. Some examples of pathogenic bacteria, you have Streptococcus pyogenes and Escherichia coli or E. coli. These bacteria can cause anything. Streptococcus pyogenes is a bacterium that can cause anything from strep throat to more serious illnesses like necrotizing fasciitis. It spreads by respiratory droplets or direct contact with the skin, and the toxins it produces can increase, its cling to the host itself. Some common gut bacteria, Escherichia coli contains pathogenic strains that can lead to urinary tract infections and foodborne illnesses. Hemolytic urinary syndrome and other complications can result from indigestion damage caused by strains such as E. coli that produces sugar toxin. Understanding these bacterial origins and its effects is essential for managing related infections and implementing public health inactives. Next is some pathogenic fungi. These fungi can cause disease in humans, animals, and plants. They differ from bacteria and funguses, in just the way that they do it. These microorganisms cause superficial or systematic mycosis in humans. Many pathogenic fungi are opportunistic, taking advantage of compromised immune systems, but some can also infect, healthy people. Common offenders include Aspergillus and Candida species, which cause anything from serious respiratory diseases to oral infections. The capacity of fungi to form spores and adapt to a variety of settings highlights their potential for pathogenicity. Given its increasing influence of fungal diseases on global health, understanding foundations of these infections is critical to efficient diagnosis and treatment. Then some, examples of pathogenic fungi. You have the Candida species and Aspergillus species. The Candida species is are common opportunistic pathogens that cause a wide range of infections, from systematic conditions to uncompromised individuals to disorders like oral thrush and vaginal yeast infections. The overall growth of these fungi in the body happen due to a disturbance in the microorganism's balance, which causes candidiasis. However, some Aspergillus species, like Aspergillus fugimentaceus, are airborne molds that can infect the respiratory system, especially in people with weakened immune systems. Aspergillosis can manifest as severe invasive infections affecting critical organs or chronic lungs disease. Candida and Aspergillus are two examples of how versatile fungi can be as pathogens, affecting various body systems and presenting serious health risks, particularly in populations with compromised immune systems. Recognizing the origins and effects of these fungi infections is crucial for timely and effective clinical management.
The next pathogenic microbe is viruses. Viruses consist of nucleic acid surrounded by a protein coat. They are infectious microbes that are similar to parasites because they require the use of living cells from other organisms for replication. There are more than 3,600 classified species, and they can affect all life forms, which include people, plants, and microorganisms. The first pathogenic virus is the influenza viruses. There are different types, but I am going to go over influenza A, which is responsible for the flu. It is a respiratory infection that is highly contagious. The only method of prevention is vaccination. Symptoms include fever, fatigue, and vomiting. Influenza viruses were responsible for a pandemic that killed 2.1% of the global population. If another influenza pandemic were to occur, it is estimated that 150 million people would die at least. The second pathogenic virus is human papillomavirus. It is responsible for HPV in adults, which can cause genital warts and some cancers. It is the most common STI. There are no cures, but treatments have been shown to be effective for the certain cancers. Around 79 million Americans have HPV, and it is estimated that 80% of sexually active women and 90% of sexually active men will have at least one type throughout their lifetimes.
All right, so next we have protozoa, and the prozoa we have is a diverse group of single cell eukaryotic microorganisms, and they are found in various habitats, including water, water or aquatic habitats, and then most of the species are free living, but all higher animals are affected with one or more species of prozoa, and infections on the prozoa are based off of what type of species and how well the resistance of the host is of that species is. Can you go to the next slide, please?
It is on my screen.
Oh, my bad. I didn't see it on mine. Sarcoidonia. First, we have the two types of species, and we have the Sarcoidonia species, and this is the cause of Entamoeba histolytica, and this is spread throughout oral and fecal route. And then the infection caused by Entamoeba histolytica, it infects the large intestine, attacking the epithelium, causing pain, tenderness, and fever. And we have the Mastigophora species. There's two types. We have the Giardia lamblia and Trichomonas vaginalis. Cause and effect. Giardia lamblia is transmitted through the food and water, and it affects the small intestine by multiplying and causes malabsorption syndrome. And Trichomonas vaginalis is a frequent cause of vaginitis caused by vaginal pH being disturbed.
Can you guys see the next slide?
Can you guys see it yet?
Oh, there it goes. Okay, so antibiotics are drugs that can be used to treat diseases caused by bacteria. Penicillin was the first of these. We still have derivatives of it, like amoxicillin. Multi-drug resistance bacteria are called superbugs, and they're really dangerous because we're eventually going to run out of ways to treat them. Main causes of this are overprescription, failure to complete an antibiotic course, and improper disposal of antibiotics. This is all just a part of exposing a bacteria to a drug, but not completely killing it, which gives the colony time to adapt over generations, and they adapt ways to resist the drugs.
Okay, I'm just going to start while we wait for the slide to show up. So then we're going to go into the importance of microbes, because as we've seen, there have been some negatives to it just through viruses, but they truly are an important aspect in our lives. So microbes are important as they help with our improving the immune system. As we've just heard, they allow us to build antibodies, and although they make them off and become resistant to it, they still allow our body to find new ways to fight them off, and it allows us as a society and in science to go ahead and come up with new different vaccines and things for them. And the microbes are also able to help aid in digestion and degrade harmful chemicals that are seen within our bodies. And they also give us vitamins, as mentioned earlier within our presentation. And then lastly, microbes are an essential to many food groups within our lives. Some foods that we see microbes in are through breads, cheeses, and even drinks like wines. These are just because microbes can be found in different soils. They're found in water, air, land, pretty much anywhere you can imagine. And these are just like where a lot of our food is planted in and comes from. So, in conclusion, microbes are something that is found within everywhere. They are found all around us, and they are important for our immune system, digestion, foods, and degrading chemicals. Although there are some microbes that are negative, which we were able to see through bacteria, fungi, viruses, and protozoa.